Hey, good morning, class. Today we'd like to talk about optimization problems for calculus. So this one is section 4.7. And so here's the step that you need to follow for solving optimization problems. So first thing that you need to do, you need to read through the problem and draw the diagram. Second thing that you have to do, identify all numbers and variables in the diagram. And then step 3, set up main equation and auxiliary equations. And then step 4, solve for the main variable in terms of the minor variable with the auxiliary equation and replace minor variable in the main equation. And then step 5, differentiate the main equation and find the critical value. And step 6, so you want to plug the critical value back into the main equation and find the max or min. So you try to follow through the steps. So this one is a little bit abstract, so it's a little bit lengthy and tedious. But some of the steps, they're kind of optional, and some of the steps, they're not considered, well, they're mandatory. So we need to follow through. Okay, so now let's take a look at that, the first one. Okay, so one example at a time. So the first one we do have find two numbers whose difference is 100 and whose product is minimum. So since we don't know what those two numbers are, so first thing that you want to do, you want to identify the variable. So let's say those two numbers, they're like x and y. Okay, x and y. So the difference is 100. So the first equation that we can set up here, it's 100. And now, got to be careful with that. The equation that we need to take the derivative. So we need to minimize the product of those two numbers. So that means x, y. So it's going to be a product. And that's the one we need to find out the minimum value. So we need to minimize the product. Okay, so anytime they see the keyword minimizing, maximizing, minimum, maximum, so that would be considered the main equation. Okay. And then the one that we set up first, so this one will be considered the auxiliary equation. Okay? So since we do have two variables, so that means we need to solve for one of the variable in terms of the other. So basically we can solve for x in terms of y, so that means x can be written as 100 plus y. Okay, so that means for the main equation, this one can be written as 100 plus y and times the quantity of the sum times y. So that equals the product. So now before we take the derivative on both sides here, so we need to distribute. So we do have 100y plus y squared. So that equals the product. Again, product, it's a constant. It's a constant, so that means a number. Okay, so now the next step, we want to differentiate it. So step 5 right there, differentiate the main equation and then find the critical value. So once you differentiate it, so we do have 100. Again, y is just the independent variable. And then plus 2y, so that equals 0. And then solve for y, so we do have y equals negative 50. Because negative 50 times 2, that's a negative 100, times plus 100, so 0. So y equals negative 50. So now we just find one number. So now let's find another number. So back to the auxiliary equation, we do know that x equals 100 plus y. So x equals 100 plus negative 50. So that means x equals positive 50. Okay, so again, so for the product, we want to minimize it, and then we just find those two numbers. So one is negative 50, and the other one it's 50. So now let's check the next one. So find the length and the width of a rectangle with the perimeter 100 meter, whose area is as large as possible. Again, the key phrase right here. So that's the area. So we need to maximize the area. So first thing that you want to do, you probably want to draw the diagram for this. So we do know that's a rectangle. Okay, so it's a rectangle with the length and the width. Okay. L and W. So we do know that perimeter, it's 2L plus 2 width. So this one, that equals 100 meters. So this one, you can use that as an auxiliary equation because that we don't want to maximize or minimize. So the one that we have to maximize is the area of the rectangle. The area, two-dimensional, length times width. So this one is quite similar to what we did for the first example. So we need to find out one of the variable in terms of the other variable. Okay, so now let me get more space right here. Okay, so the step that we just followed through. So I'm sure you guys have this one written down already. Okay, so now for the main equation, we just want to put in one variable in terms of the other. Well, starting with the auxiliary equation first. So perimeter, we do have 2L plus 2W, so that equals 100 meters. And now, divided by 2 both sides, so we do have L plus W equals 50. So that means L equals 50 minus W. And for those who might be wondering, does that really matter which variable that we solve to isolate? It doesn't really matter, because now we want to find the length and the width, both of them. So we can find out either one of the variables first. So now the next step. So the next step, we want to put in this one to the main equation. So for the area, we have length times width. So that means length, which is 50 minus W, times W. And don't forget, the area of the rectangle, that's the one we need to maximize. So in other words, that means we need to use this one to differentiate. So first thing that you want to do, multiply things out. So we got 50W minus W squared. Again, area, that's just a constant. So derivative of a constant, it's always 0. And now derivative on the right hand side, so we do have 50. Derivative of W squared, we do have 2W. So that means W equals 25. So the width is 25. And guess what the length is? Okay, don't forget about the units, 25 meters. And then the length, so whatever the value that you find out for the width, you want to put it back to the auxiliary equation, the one that you isolate the variable with. So we do have 50 minus 25. So 50 minus 25, we do have 25. So 25 meters, and that's the length. So for those you're probably wondering, well, it's going to be a perfect square. It is. Okay, so a square can be a rectangle, but the rectangle cannot be a square. And hopefully that's something you learned from geometry. And now let's see what else that we did. Okay, so back to the first one, they're quite similar. So now, let's go through the next couple examples. So I need to flip this one over. Okay. So you might be wondering, there's some kind of music going on. Yes, so just the background. So just want you guys to relax a little bit while you're learning optimizations. Okay, so now for the next one. So if 2,400 square centimeters of material is available to make a box with a square base and an open top, find the largest possible volume of the box. Okay, so the key word, key number, key phrases. So we do have 2,400 square centimeter of the material. Okay. And so you might be wondering, this one is considered two-dimensional element. So this will be considered the surface area. Now, one thing that you need to be careful, we do know that it's a box. Okay, so what kind of box is that? So with the square base, okay, so it's a square base with the open top. That means the box is going to be like this. Okay, it's a square base. So that means the side going to be all equal. And then the height, we don't know what the height is. But one thing that we for sure, it's an open top. So this one's an open top. So that means the top part right here, it's open. So let me just shade this area. So it's a square base, open top box. Okay, so that means we can set up one of the equation as the surface area. So surface area, we do have side times the side. So we do have 1, 2, 3, 4, 5. So 5 surfaces. Okay, so let's see. Well, let's just start with that, the bottom base first. So that's S squared. And then the side, we do have S times H, S times H, S times H. And we do have 1, 2, 3, 4 of those. So 4SH. Again, the top part, it's open, so we don't count the top surface. So the bottom base plus the 4 on the sides, front and back, left and right. So we do have the surface area for this open top box. So it's 2,400. Okay, so now the next thing that we need to do, we need to maximize the volume for the box. Okay, so the volume for the box, the way that we find the volume, back to geometry, it's the area of the base times the height. Okay? So now, one thing that you need to find out, you need to determine which one is the main equation. So, in order to find out the main equation, we need to find out the element that we need to maximize or minimize. So we need to find the largest possible volume, so that means this one will be considered the main equation. And then the other one is the auxiliary equation. Okay, so since we don't know what h is, so maybe we can isolate that h by itself. So in order to isolate h, so we subtract s squared both sides. So 2400 minus s squared. And then from here, divided by 4s. Okay, so h equals 2400 minus s squared over 4s. Okay, so now for the volume, again, volume, that's a constant, so let's just rewrite it as a constant, v. And then s squared times the quantity of 2400 minus s squared over 4s. Again, don't forget, the main equation is the volume, so that's the one we need to differentiate and find the derivative. But before you find the derivative, you want to reduce. So cross cancel, and then we try to separate it, distribute. So 2400 divided by 4, so then that would be 600 times s, so 600s. And then over here, so s times s squared, so then we do have s cubed over 4. Distribute. Again, this one is just the simplification. Now we want to take the derivative. Derivative of the volume constant is 0. Derivative of 600s, 600, minus 34 s squared. And now from here, you want to solve for s. So that means we do have 600 equals 34 s squared. And then times 4/3 both sides. Okay, so 600 times 4/3. So that equals s squared. So we do have 200 times 4, which is 800, equals s squared. And then square root both sides. So this one can be written as square root of 100 times square root of 8. So square root of 8, that's 2 root 2. And then square root of 100, that's 10. 10 times 2 root 2. So we do have 2 root 2, not 2 root s. So we do have 20 root 2 equals s. And the unit for this one would be centimeter. So we find the side. Now you need to find the height. The way to find the height, so basically just plug in a number back to the auxiliary equation, the one that you isolate. So h, so that equals 2400 minus s squared, which is 800, divided by 4 times s, 20 root 2. So 2400 minus 800, so then that would be 1600, divided by 80 root 2. So 1600 divided by 80, then that would be considered 20 over root 2. You can reduce it first. 20 divided by root 2, multiply root 2 top and bottom. So 20 root 2 over 2. So we do have 10 root 2. Again, centimeters. So now the example is just getting a little bit more complicated. So now take a look at the next one. So the next one, find a point on the line. 6x plus y equals 9. So that's closest to the point, -3, 1. So here's one thing I would like you to think about. You know, the formula that you need to apply, any, like the previous concept, things that you learned that you need to apply for this type of problem. Okay, so, well, one thing that you want to do, you want to sketch the graph first. So we do know that's xy coordinate. So the given point is negative 3, 1. Right up here. Okay, and then the equation that we have for the line is 6x plus y equals 9. So try to sketch the graph like this. So you want to come up with a slope-intercept form. So y equals negative 6x plus 9. So that means the slope is negative 6. And then the y-intercept, it's 9. Okay, so just make the scale a little bit smaller. Okay, so what we got, it's negative 3, 1. And then it's 1, 2, 3, 4, 5, 6, 7, 8, 9 up here. And then the slope is negative 6, so it's negative 6 over 1. So down 6, and then 1 to the right. So which is right there. Now you might be wondering, looks like it's not being cut off, okay? So this one, they're not going to intersect, okay? So they're not going to intersect at all. So here's the line. So we need to find out the closest distance. Now back to geometry. In order to find out the closest distance, you need to use the distance formula. So the closest distance would be the point which is perpendicular to the line. Okay? So this one guarantees that's the shortest distance. So that means for this one we need to apply the distance formula. Okay, so we'll look at that. So just need more space up here. Distance formula. So the distance formula we have is square root of x2 minus x1 quantity squared plus the quantity of y2 minus y1 squared. Okay? So one thing that we just solved for y in terms of x. And the point that we have, let's say this one is x1, y1. Oops, x1, y1. And then we just want to set up the distance formula here. So distance equals square root of, so x2, so which we don't know what that is. Yeah, this one is x1, y1, the point that we have. So x2, y2 would be the point right here on the line. Okay, so x2, so just say that, well, just x. Minus x1, which is negative 3. Quantity squared. y2, so y2, again, we don't know what that is, but that's the y coordinate on the line. So we can use this equation here. So it's negative 6x plus 9, which is considered y2. And then minus y1, so y1, which is what? 1. Okay, quantity squared. You can use bracket, you can use parentheses again. Okay, so now the next thing that you want to do, since we do know that d is the constant, so we can just square both sides, so we can start with that d squared. So constant squared, it's just another brand new constant. And then the radical, we can just simplify the radical a little bit. So negative, so that means positive, so x plus 3, quantity squared. And then over here, negative 6 plus 9 minus 1. So that means negative 6x plus 8. And then quantity squared. And now from here, we can just differentiate it. It's easier to differentiate the distance formula without the radical. Because we do know that d is a constant, so derivative of a constant, d squared, you just nothing, 0. And then derivative of the rest of this, so we do have 2 times the quantity of x plus 3. And then plus 2 times the quantity of negative 6x plus 8. And then times the inner function, don't forget about the chain rule. So derivative of the inner function, which is negative 6. And for those students might be wondering, what about the derivative of the inner function? Well, that's just 1x plus 3, so which is just 1. So you multiply by 1, is that just the original element? So now the rest of this, we just want to solve for x. So multiply everything out, and then combine the like term. So we do have 2x plus 6, minus 12x plus 16. Okay, so this one, got to be careful. There's a negative 6 right here. So actually we do have negative 6 times 2. So that's negative 12 times negative 6. So then that would be positive 72x. And then negative 6 times 2, negative 12 times 8. Okay, negative 12 times 8, then that'll be negative 96. Minus 96. So you're going to be careful with the way that you distribute with the arithmetic. So one thing that just mess up, everything else just collapse, okay? So one more time, so 2 times negative 6, negative 12, times 8, negative 96. So 2 times negative 6, negative 12, times negative 6x, positive 72x. And now combine the like terms. So we do have 2x plus 72, 2x. So we do have 74x. And then 6 minus negative 96, so then that'll be negative 90. But you want to move that negative 90 to the left-hand side, so that turns out to be positive 90. And then solve for x, divided by 74. Divided by 74, so we do have x equals 90 over 74. So divided by 2. So we do have 45 over 37. So that just gives you the x value. So in order to find out the y value, so all you need to do is just plug in back the number to the auxiliary equation. So we do have y equals negative 6. So negative 6 times 45 over 37 plus 9. Okay, so you just want to find out what that is. Okay, so now for the next two examples, so we'll take a look at that. So find the area of the largest rectangle that can be inscribed in the circle x squared plus y squared equals 1. Okay, so now this one is just like going back to geometry. Would you know that's the equation of a circle? That there's an inscribed rectangle inside a circle. Okay? So what do you think that is? Is that going to be a rectangle or is that going to be square again? Okay, so again, the key word, circle, inscribe. Okay, so now let's take a look at that. Hey, can you guys be quiet down? I'm recording right now. So it's a circle with the radius 1. Okay, so now there's an inscribed rectangle. Okay, so let's say the point right here. So let's say this one's x comma y. Like that. Okay, so now let's find out what that is. X squared plus y squared equals 1, so that's one of the equation we know. So we need to maximize the area of the rectangle. So we do have, well, the rectangle, we do have a length and a width. So area, the length, and the width, multiply them together, so then that'll be the area. But one thing that we need to find out, it's the length. Okay, so one thing that for sure we do know the length in terms of x. So this one is x comma y, so that means down here will be negative x, positive x comma negative y. So that means the distance here will be 2x. Well, actually, it's it's 2y. Okay, so 2y right here. And then the distance here, so we do know this point, it's considered negative x comma negative y. And then the one up here, so then that'll be negative x comma y. So the distance down the bottom would be considered, okay, so x minus negative x, so then that'll be 2x. So the length would be 2x, well 2y, and then the width would be 2x. So that means the area would be 4xy. Again, since we're dealing with two variables, so we need to isolate one of the variable in terms of the other. Okay, so main equation that we have is 4xy, so that's the area we need to maximize, so main equation. So now let's just solve for one of the variable in terms of the other. So we got y equals 1 minus x squared, and then square root of the whole quantity. The reason why we just want to keep the positive value because we just want to make sure that this one's a function. If that's positive, negative, then that won't be a function. Okay, so we do have area equals 4 times x, and then times square root of 1 minus x. And so now before you differentiate it, so let's just square both sides. So we do have area square, so area square, square both sides here. So we do have 16x squared times 1 minus x. Again, exponent, you want to distribute to each element, so that's why you need to square the number, square the variable, and then square the radical. And now, before you differentiate it, you probably want to distribute. So we do have 16x squared minus 16x to the power of 3. So after you differentiate it, so we do have 0, 32x minus 48x squared, and then solve for x. So we do have got the greatest common factor, 16x. So we do have 2 minus 3x. And then from here, you want to solve for x. Okay, so just want to check one thing real quick. Greatest common factor, 16x. So we do have 2 minus 3x. So x equals 0, x equals 2/3. Now the thing is that x cannot be 0 if x equals 0, so this one, it won't be a rectangle. Okay, so x equals 0, so it doesn't apply. So it's only for 2/3. And now in order to solve for y, so we plug in a number back to the auxiliary equation. So y equals square root of 1 minus 2/3 quantity squared. So square root of 1 minus 4 over 9. So we got root 5 over 9. So that means y equals root 5 over 3. Okay. So we solve for x and y. And now you want to find out the area of this rectangle. So we got x equals 2/3. So we do know that the area of this rectangle is 4xy. So 4 times 2/3 times root 5 over 3. So we do have a root 5 over 9. And that's the area of this rectangle. Okay, so now let's finish the last example here today. So find the equation of a line through point 33 that cuts off the least area from the first quadrant. Okay, so now let's take a look at that. 3, 3. So that's in quadrant 1. And this one is showing that, so the line cuts off the least area of the first quadrant. So that means going through this way. Okay, so that's a straight line here. So 3, 3. So for those you might be wondering, so it's the least area. Well, as you can see that the first quadrant, the boundary area is a triangle. It's a right triangle. So 3, 3, that's just the point, the line going through. But the thing is that we don't know exactly the length, the base, and then the height of the right triangle here. So let's say this one is x comma y. Okay, x comma y. So let's say that we do have a point here. So this one is x comma 0. And the point up here, this one is the y-intercept, so 0 comma y. Well, because that's going to intersect the x-axis and the y-axis. So one thing that we can do, we can just set up the slope. The slope of this part of the line segment, which is the same as the slope of the other part of the line segment. So the slope formula, we do have y minus 3 over 0 minus 3. So that's the slope. And then down the bottom, similar. So 3 minus 0, over 3 minus x. So we do know that's the same slope. So we try to simplify that a little bit. So y minus 3 is this over negative 3, which is the same as 3 over 3 minus x. Well, because that all the points here, they're all considered collinear. That means the slope got to be exactly the same. Now again, this one is not the main equation, it's just auxiliary equation. So we can just solve for one variable in terms of the other. So we try to solve for y by itself. So we do have negative 1/3 y, negative 3 over negative 3, then that would be positive 1. So we try to solve for y, so we subtract 1 both sides. Well, another thing that I can do, you can always cross multiply, it's easier. So let's just cross multiply this. So we do have y minus 3 times the quantity of 3 minus x. So that equals negative 9. Again, so we try to solve for y by itself. So y minus 3 equals negative 9 over 3 minus x. And then add 3 both sides. Okay, so that would be the auxiliary equation. And now back to the instruction here. So the one that we need to minimize, so then that would be the area. Well, actually we need to maximize the area. So we do know that's a right triangle. So the area of a triangle is 1/2 times x times y, because x is the base, and then y, which is the height. So now we do have two variables, so that means we need to put in that y there, the one that we just isolate with. So we do have 1/2 x times the quantity of negative 9 over 3 minus x plus 3. Okay? Again, area, that's a constant. So now before we take the derivative, once again, you want to distribute. So once you distribute, you do have 1/2 x times this. So that means it's negative 9 over, well, it's negative 9x over 2 times the quantity of 3 minus x. And then plus 3/2 x. Okay, so let's just check that. Multiply fractions straight across, so negative 9 times x, negative 9x, and then 2 times the quantity of 3 minus x. And now you want to differentiate it. So derivative of constant, 0. And this one right here, you want to use the quotient rule. So derivative of negative 9x, negative 9, times the quantity of 2, times 3 minus x, minus derivative of the bottom part. After you distribute, this one turns out to be 6 minus 2x. So that just turns out to be negative 2, derivative of this whole thing. And then times negative 9x, all over the quantity of this square. So then that would be 4 times 3 minus x quantity squared. It's the quotient rule. And then plus derivative of 3/2 x, 3/2. And now for the rest of this, so you want to find out the zeros. Well, we do know that the denominator cannot be 0 because that would be 3. In 3, that's the point we have already. So we need to figure out the value of x. Okay? So the way to find the value of x, so we want to combine this together, and then we want to set the numerator equal to 0. So let's try to simplify this a little bit. So we got negative 18 times 3 minus x, and then negative, 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 so 3 negatives, so we do have minus 18x. So that's all over 4 times the quantity of 3 minus x squared, and then plus 3/2. So in order to combine this together, we need to find the least common denominator. So the least common denominator would be 4 times the quantity of 3 minus x squared. Okay, so that means it's going to be written as negative 18, 3 minus x. I just want to transfer this one all over here. Plus, so common denominator is 4 times this quantity, 3 minus x quantity squared. So that means the top and the bottom, I need to multiply by 2, and 3 minus x quantity squared. Okay, so set equal to 0. So that means the numerator got to be 0. So we do have negative 18 times 3, which is negative 8 times 3, 24, so negative 54, minus positive 18x, and then minus 18x, plus 6 times the quantity of 3 minus x quantity squared, so expand it. So we do have 9 minus 6x plus x squared. Again, we set it equal to 0, just the numerator. While denominator, don't worry about because we combined them. And now it looks like we can cancel this out. So we got negative 54 plus 6 times 9, 54, minus 36x. Positive times negative, negative. And then 6x squared. So this one got canceled. So we do have negative 36x. Let's just rewrite it from the greatest power to the least, because that's a quadratic. So 6x minus 36x. So take out 6x. So we do have x minus 6. So that means x equals 0 and x equals 6. Well, but the thing is that x cannot be 0. If x equals 0, it doesn't apply that with the equation here. So that means x can be 6. Okay, so 6, which is all the way over here. And then solve for y. Okay, so solve for y. And now we do have negative 9 over 3 minus 6 plus 3. So we got negative 9 over negative 3 plus 3. Again, as you can see that this one turns out to be 0. Well, actually, it's going to be 6. So 3, 3, 6, 6. Well, 3, 3, that's just the point. 6, 6, that means it's the base and the height of the triangle. So the area of this triangle which is 1/2 times 6 times 6. And that'd be 18. Now, but the thing is that we need to find the equation of a line through the point. So this one gives you 6. So that means this one is 6 comma 0. So the point up here, so 0 comma 6. So that means the slope of this line, what do you think that is? So it looks like it's going to be negative 1. And then writing the equation of a line. Okay, so writing the equation of a line, so we get the slope, plug in a number, so 6 minus 3, 0 minus 3, so 3 over negative 3, which is negative 1. Decline, negative slope, so y minus the position, 3, the slope, negative 1, and then x minus 3. So y equals negative 1x plus 3, plus 3 again. So y equals negative 1x plus 6. And also you can tell just by plugging a number. The y-intercept is 6, the slope is negative 1, so negative 1x plus 6. But the way that I'm doing it, just want to double check the process. Okay, so thank you for watching the video today. And I'll see you guys next time.